figure this out. All right, so what was the x component of D? It was this guy. And the y component of D was this guy. And this x component is in the negative x direction, and so there's the negative sign. It's negative 16 units, and this guy is 12 units, positive 12 units. All right, now, okay, so oftentimes, well, you don't want to figure out these angles and so on. So what you want to get used to is the following, okay? So for a right angle triangle, here is the hypotenuse, here is the adjacent side, here is the opposite side. This angle theta, the opposite side, the adjacent side is the hypotenuse times cosine theta, and the opposite side is hypotenuse times sine theta. Okay. So now let me apply that to this guy. So here's the hypotenuse, here's 37 degrees, okay, and there's 20. So this is the adjacent side, so this is 20 cosine 37. This is the opposite side, this is 20 sine 37. Okay, now we have the magnitude of these sides. Okay, but this side for our vector is in the negative x direction, so the x component will be, you would put in the sign by hand, 20 cosine 37, and this would be 20 sine 37. Okay, so you put in the sign by hand and figure out the components adjacent and opposite sides. Okay, and this is an easier way to do it. Okay. You can check out those numbers, they'll work out the same. Okay, so our vector D is minus 15.97I plus 12.03J. Okay, we have to figure out one other vector, F. And 20. All right, so the x component, this is the adjacent side. Okay, the magnitude of F is 20. This side would be 20 cosine 30. Okay, this side would be 20 sine 30, but this is negative, so F, you guys understanding this?
Yes.
20 cosine 30, you're putting in the sign by hand, 20 sine 30, and again that's negative. Okay. So here when you use an acute angle, these numbers always work out to be positive, and so you have to put in the sign by hand. Or you could, if you like, you could figure out the angle, this angle, what is that angle equal to? 210 degrees. And that's equal to 20 cosine 210I plus 20 sine 210J. Okay? But like I said, using acute angles makes life easier. All right, now we have our three vectors. Okay. So A was 8.66 plus 5j. Okay, so you should be able to find this. This is all right. So it's just 8.66 plus 4 times that plus minus 2 times this, and so on. That's the ith component. And the jth component will be 5 minus 4 times that minus 2 times that plus 2 times. Okay. So again, whenever you're doing vectors, the first thing you do is find the components of the vectors. Okay. So I guess I won't do this problem. It's just setting up adding a whole bunch of vectors. So I'll show you how to get started. So in an attempt to escape a desert island, a castaway builds a raft and sets out to sea. The wind shifts a great deal during the day and he's blown along the following directions. So 2.5 kilometers, 45 degrees north of west. So the first vector is, we'll call it vector 1, 2.5 kilometers, 45 degrees. Okay. And then when he gets there, the wind changes. And now the second displacement is then 4.7 kilometers, 60 degrees south of east. And then he'll be going somewhere like that, but we are going to draw the second vector from here. Vector 2, 4.7 kilometers, 60 degrees south. Okay, and so on. So draw all the vectors, find the components, and just add them up. Okay. Now, when the angle is clockwise, that's a negative angle in the formula. Okay. Or you could just find the components and put in the sign by hand. Okay. So this would be 4.7 cosine 60. This would be 4.7 sine 60. And that's negative, that's positive. Okay. And so on. Right, so we'll do this one here's three-dimensional vectors, and so let's find that. So they say find the displacements and their magnitudes. So we'll find this. D is 2A minus B. Okay. So there are the components. So 2x, that's 6 minus 2, 4i. And then minus 8 minus 3, that's minus 11j. And then 8 minus of minus 7, that's 15k. So that's the vector D. And the magnitude of D is square root of dx square plus dy square plus dz square. Okay, so that formula can be generalized to any number of dimensions. Okay, so that's the distance from the starting point. And that's in meters. Okay. You guys understand? Any questions on that? So there's the displacement, and there's the distance magnitude of the displacement. So they give you a D is that, there's B and there's A. Find the unknowns A and B. So what does this equation tell you? A times the vector D plus B times the vector B plus the vector A is equal to the 0 vector. And they want you to find A and B. So how many unknowns do you have? Two. How many equations do you need? Two. Well, these seem to have one equation. How do you solve for A and B? Substitution where? Well, the problem is you only have one equation. So here's the deal. Okay, when this is really two equations. When A equal to B, what this means is AX, if these are two-dimensional vectors, AX equal to BX, AY equal to BY. Okay, so when you have this equation, if it's these are two-dimensional vectors, this is really two equations. If it's a if they're three-dimensional vectors, you have really three equations. Okay, And if it's an n-dimensional vectors, this is really n equations, okay? So that's the difference between the number 0 and the 0 vector, okay? This 0 vector is really 0i plus 0j, okay? These are two-dimensional vectors. So a dx plus b bx plus ax equal to 0, and a dy plus b by plus. Okay, so there are the two equations, and now you can solve them. Okay, so let's write them down. A dx is 6, b bx is minus 8b, okay, so what you have is 6a minus 8b equal to minus 26. All right, there are your two equations, and you can solve for a and b. Does anybody want me to solve this, or you guys got it? Okay. So one way of doing this is, we'll get this coefficient to be the same. Okay. So we'll multiply this by 4 and this equation by 3. Okay. So you get 24a minus 32b, and 4 times that is 104. And this is minus 24a plus 9b minus 57. So now we'll add the 2, this cancels, minus 23b. Uh, 161.7, and then so a would be, we can substitute for that there. That's 56 over there. That becomes 30, and a is 5. So again, when two vectors are equal to each other, that means their corresponding components must be equal. Okay. So if vector A is equal to B, the only way vector A will be equal to B is when x component of A is equal to x component of B, and so on. Okay. And that idea can be generalized. You guys will have, you will do matrices. If two matrices are equal to each other, that means every element is equal to that corresponding element. Okay. Just like that. And of course, in math, you'll learn a vector is a column vector. Column vector. A vector is a column matrix or a row matrix. Okay, so this says find the angle between vectors. They give you all these vectors. So we'll do this 3-dimensional vector. Okay, so they're asking you to find the angle between these two vectors. Okay, so whenever you want to find the angle between two vectors, you need something that involves that angle. What involves that angle? The dot product of the two vectors involves that angle. The cross product also involves that. Okay, so but we'll do the dot product. So d dot b is dx bx plus dy by plus dz bz. But the dot product is also given in terms of the angle db cosine theta. Right. Since we have the components, you can calculate this number. And since you have the components, you can calculate the magnitudes of that. Okay. And since so dx bx plus dy by plus dz bz equal to db cosine theta. Okay, you can calculate this guy, you can calculate these guys. So this is the only unknown, and you can solve for cosine theta. Okay, and then get the angle from there. So cosine theta is dx bx dy by plus dz bz divided by d. Okay, dx bx, that's minus 4 minus 12 is minus 16 plus 2, that's minus 14 divided by db. D is square root of 4 plus 16 plus 1. .58. B is square root of 4 plus 9 plus 4. Okay. So cosine theta is minus 14 divided by 4.58 times 4.12. Okay. All right, so we've done a problem with dot products. Now we'll do a cross product. Okay. So we'll pick three-dimensional vectors. So here's an A that's three-dimensional. Here's C that is three-dimensional. So let's find that. So A cross C. Okay. Now, if you do enough problems, you'll remember this. But if you, in the on the exam, if you don't remember the cross product, I can give you the cross product. Okay, so this would be the x component is AYCZ minus AZCY plus the y component is AZCX minus AXCZ plus the z component is AXCY okay. All right, so this is, and when you do determinants, it's minors. Remember when you do determinants, I, J, K. So these guys really are the minors. I times this minor, which is that guy, and so on. Okay. All right. So the x component is minus 40 minus 4. So that's minus 44i. And then AZCX. AZCX, that's 3 minus 20. That's minus 17j. And then plus AXCY. AXCY. So that's 8 minus of minus 12. That's plus 20. Okay. There's the vector. Do you want me to do another example, or are you guys good with that? Okay. Pick one. I guess it makes sense to do a three-dimensional one. Okay, we'll do B. B is another three-dimensional one. All right, so here's the point. See, notice something. This is A, and that's C. In this problem, they've just switched them. C became A, and A became C. So in the first problem, you did this vector cross with this, and in the second problem, you're doing this vector cross with that. So the answer should be negative of this vector. That's the point of that problem. Okay, you guys understand? You saw that A cross B is negative of B cross A. And so that's what they're trying to illustrate. Okay, so let's do that cross product, and we should get the same answer, well, negative of this answer is what we should get. Okay. All right, so again, A cross C is AY CZ minus AZCYI the y component is AZCX minus AXCZJ plus AXCY minus AYCX. Okay. All right. AYCZ minus this. So that's 4 minus of minus 40. So that's plus 44I. Okay. I have trouble with this one. Who wants to help me with this one? AZCX. That's 20 minus 3, 17. And then AXCY, that's minus 12 and minus 8, so minus 20. And this should be negative of that previous one, which it is. Okay. All right, so you will need to do this in your higher level engineering classes and stuff like that. You'll have a vector, and you will need to find the projection of that vector along, let's say, various axes. Okay, so if, let's say, here's a building, what is the length of the shadow when the sun is directly overhead, and so on. Okay, so you're finding projections of vectors along various axes. Okay. Now you saw, so here's the generalization. Okay, so let's say you have a vector A dot B. What is it equal to? A B cosine theta, where theta is the angle between A and B. Okay. Okay, so let's do this. A dot I. So what does that turn out to be? Okay, so that's the vector A, the magnitude of A. What is the magnitude of I? 1. And then cosine theta. So if you take A dotted with I, A cosine theta, the angle theta is between A and X. This is the projection of A along the x-axis. That's the x component. Similarly, if you want the y component, and this could be any vector J is, and this turns out to be AX, this turns out to be AY, AZ. Okay? So that's the general idea. Okay? Now, in these problems, theta would be the angle between A and X, but they don't give you that angle generally. Okay, so what we'll have to do is, so let's say, so for instance here, they've given you the y component of G. There's a typo here, that should be GY. See, that's the y component of that. Okay, so what we'll do is, here's G, we'll find the projection of G on the xy plane, and then take the component y component. Okay, so we are doing two projections. Do you guys understand that? All right, so I'll write it down and then let's see if you understand it. By the way, how many numbers do you need to specify a three-dimensional vector? Three. Okay, this is a three-dimensional vector. Let's see how many numbers they've given to us. They've given this one number, they've given this one number. They haven't given us the magnitude, but they've given us the y component. So they've given three numbers. So they've given this angle is generally called theta, and this angle is called phi, 60 degrees, 45 degrees, and gy is 10. They've given us three numbers, so they have specified the vector. So we should be able to find the magnitude of the vector, okay? And that's the idea. Okay. For this vector, have they given us three numbers? Yeah, so they've given us this angle, they've given us this angle, and they've given us this component, okay? So for this vector, they've given us, again, that angle is called theta. Theta is 45 degrees. Phi is, so you would measure phi from the x-axis, and that's 120 degrees. And HY is 15 units, okay? So again, they've given us three numbers, so they've completely specified this vector. So they've specified this vector as well, okay? So they want you to find the scalar components of the three-dimensional vectors. So they've given us these numbers, and I'll do just one, and they want us to find gx I plus gyj plus gzk. They've given us these numbers, and they want us to find these three numbers. Okay, well, gy is given, but those are the numbers we want to find. That's the problem. You guys understand? Okay. All right, this is a 45-degree angle. So gy should equal gx. This side is equal to that side, okay? So you see that for our problem, gx is equal to gy. Okay? So we already have that, so which is 10. Okay, now it's just a matter of finding gz. Gz is this guy. They've given us this angle, so this is an easy problem, okay? So g dotted with k equal to g cosine 60 equal to gc. They've given us this angle, okay? So, oh, well, we don't know g. We have to find g first. Okay, now here's I'll write gx is okay, so gx is the following. This angle is 60 degrees. I guess this diagram is not that good. This angle is 30 degrees, right? This angle is 90 degrees, so this angle is 30 degrees. So g cosine 30 is this projection, and then cosine 45 this projection times cosine 45 is gx, which is that. So 10 equal to g cosine 30 cosine 45. Okay. So now you have the magnitude g. So G is equal to 10 cosine 30 cosine 45. Okay, so 16.32, and so GZ is G cosine 60 So what we have found is the vector G is 10I plus 10J plus 8.16. All right, so the problem was they gave us these three numbers and they wanted us to find those three numbers, and which we did. Okay. All right, guys.